Hello, it is the last unit we're going to do today, unit 4, but it might be one that you haven't remembered because we did it way back in the fall, and a couple things I'll show you, but I'll help talk you through it, so it should be fine. Okay, so you're looking at this first graph, so we're back to remember when we did lines on the graph and your favorite equation in the world was y equals mx plus b, and m was the slope, and b was the y-intercept. And you're like, well, what does that really mean? Slope, again, is the rise over run of the line, and the y-intercept is where it crosses the y-axis. So if you remember, what we used to do is we had a highlighter, and we would highlight the y-axis. Oops, that's not very good right there. So, and we would, make an obnoxious bullseye right there. So that right there is where it crosses the y-axis, which is the number 1. So in your equation, it would be, I know it's something x plus 1. Okay, so that part I did. Now, the rise over run, well, it's not rising, it's actually falling if you look at it left to right. But if I go from this point to this point, it's going down 2. Remember, we used to do that, and over 1, 2, 3. So that's a negative 2/3 would be my slope. So the whole thing put together would be that. So that's what we were, remember, you're doing that long, long time ago. Okay, and we did a whole bunch of stuff on this. And also, one of the things we learned is if we don't have a graph to do the slope, we have the slope formula. And we used to do x1, y1, or you can just x and y, x2, y2. And so the way you would tackle this one is the first thing you'd have to do is say, okay, well, I need to figure out the slope of this line. So I'm going to do the y. Remember, it's the change in y over the change in x, which means subtract the y's, which is 5 minus 3, because those are the y's, and you go backwards. So I go this one to that one. And 4 minus 5. So that gives me 2 over negative 1, which is really negative 2, and that is my slope. Okay. Then step 2 was, if you remember, you have m, but you also need b, because that's part of the equation. So we would say let it be. So we start out by writing a whole new line, and we pick one of these points. These are both pretty easy, but I'm going to pick this point to use as my x1. Remember when we used to make a table over here? X, y, x equals, y equals, m equals, and we just let it be. B is what I'm trying to figure out. But I know if I pick this point that x is 5 and y is 3, and I already figured out that m was negative 2. So I'm going to drop those in the equation. So I'm going to say, all right, 3 then equals negative 2 times 5 plus b. So 3 equals negative 10 plus b, and then I'm going to try to get b all by itself. So 13 equals b. So I need these two numbers to do my final, you remember I used to call it the rectangle of success? You got to put it in the equation and put y and x back in. So it's y equals negative 2x plus 13. That's your final answer for that one. I know, it's an oldie but a goodie. We haven't done one of those in a while. Okay, number 19 says, all right, is the ordered pair, and don't forget the first number is always x, the second number is always y, negative 3, 7, a solution to this function? So basically they want to know if you put in a negative 3 and a 7, is this going to work? So that's exactly what I'm going to do. I'm going to say, okay, does 7 equal negative 2/3 times negative 3 plus 5? Okay. Couple things to remember. Don't let the fraction scare you. You can always put this over 1. And the first thing I'm going to notice is if I have two negatives, if I'm multiplying, my answer is going to be a positive. And the other thing I'm going to notice is that if I remember my fraction rules correctly, I can cancel, turn that into a negative 1. So negative 1 times negative 2 is positive 2 plus 5. Oh, hey, look, 7 equals 7. Checks. So yes, negative 3, 7 is a solution. So as long as it works, that's what we do. Okay, that's how you do that page. I know, those are blast from the past. Okay, on this page, now we can start into the real life application of slope and y-intercept. So it says, Tony joined the book club. He receives 8 free books when he joined. Okay, So 0, your starting point right there, that's B. So guess what I know? Because the B is also the starting point. And the graph, it's where it crosses, but in real life, it's where things start. And then it says, which equation can be used to find the total number of books N that Tony will have from the book club after T months? So the first thing you got to look at is what's the table going up by? So every time you think of this as your X and you think of this as your Y, every time this goes up 3, this goes up 1. So the change from Y over X is 3 over 1, which is 3. That number is your rate that it's going up, which is also known as your slope, which is also known as letter M. So guess what? You have your equation. It's Y equals, if I put that in, 3X plus 8. So I go to my choices and okay, Y isn't really Y though. What letter are they using for it? They're using N. So it's N equals, and for X, they're really using T. So 3T plus 8, which is letter D. So this equation, if you break it down, means it starts at 8, which it does, and it goes up at a rate of 3 books per month. That's what he gets every month. Okay. Kind of feel like being in a book club right now, so I have something to read while we're home. Next one, Pat's Power Washing charges $2 per car. All right, when I see the words per, that's always a rate word. Okay, and that means that that's going to be your M. To cover the cost of cleaning supplies, plus 49 cents per minute. Oh no, per car to cover, and 49 cents per minute for the use of water sprayers and vacuum. That's also a rate. Uh-oh, now I got 2 rates. I got to figure out which one it is, and which one's the rate I want to use as M. Write the equation for the total charge for washing the car for any car wash time T. Okay, so guess what? This isn't the rate anymore. This is actually going to be the start. Take that back. I said I jumped the gun. That's the start. That's B, because they're always going to charge every car $2 no matter what. So, but the longer you're there to wash your car, that's when they're charging you 49 cents per minute. So write the equation for the total charge C. So C, total charge, is equal to 49 cents per minute, which minute is T. They're using T for time, that's the minute. Plus, they're going to charge you $2 up front. So that's actually the equation. That's your Y equals MX plus B. We do a little more practice on that later on too, in case that confused you. But the starting amount would always be $2, and the cost is more if it takes you like 5 minutes to wash your car versus 10 minutes to wash your car or vacuum it out. I always run out of time on these things. They always do the automatic ones and then it dies off. Okay, the next one. The data on the table is a linear relationship, which then means it can be represented with Y equals MX plus B. Describe how you can find the Y-intercept of the line that represents the data. Okay. The y-intercept is where it starts, and things start at 0 on the x-axis. So I know why'd I use that one? There it is. That's where you find the y-intercept. It's always 0 something, and in this case, it's 3. So the y-intercept would be 0, 3. Or you can even just say b equals 3. The same thing. Oops. Just like that. Okay, next page. 23. The function below represents the pricing plan for car rentals, where D is the number of days and C is the cost. One of the car rentals, order the car rentals from least to greatest based on their rate of change. Okay, so how am I going to figure this out in the first one? Well, okay, what's the rate of change? Well, the cost for this one, it seems, goes up $30 every day. Now, is that a consistent thing? So 130 to 250 is a change of 120, right? But it's over 4 days. So technically, if you divide 120 by 4, you're going to get 30 again. So far we got a constant rate. And then if I check out this one, 250 to 460, that's a change of 210 over 7 days. Guess what? 210 divided by 7, also 30. So the rate on this one is $30 basically per day. That's your rate. All right, the next one, it says Total cost is $30 plus $25 per day. Okay, so that means the rate on this one is $25 per day. That's easy. I'll just do that right off the bat. And finally, on the last one, the rate for this one is messed up because you got to end up solving this to get it in the right order. So you got to solve this for C. So if I take away the $7.70 and I move it to the other side, so in this case, I get negative 0.25 C equals negative 7D minus 10, and I have to divide by 0.25 and divide everything by 0.25 and divide that by 0.25. Okay, divide by that, divide by that, divide by that. Then what happens is I will get the equation for this being C equals, okay, got to get my calculator out for this one. All right, so I'd move the 70 over, I'm dividing by 25 cents. So I'm saying 7 divided by 0.25, and it is a negative 7 and a negative, so it's going to be a positive. So that turns out to be, if I simplify that, 28D, and then if I do that one, negative 10 divided by negative 0.25 plus 40. So in that case, when I simplify it and make it look nicer by solving it for that, this number right here, that's my rate. So my rate is $28 per day. So ordering from least to greatest, the cheapest one is Enterprise. They would be number 1. And then Hertz, they would be number 2. And finally, Avis would be number 3 because it goes 25 per day, 28 per day, and 30 per day. Okay, so that's how that one goes. That took a little work. Okay, 24. The graph below shows the number of pies to produce at the bakery as a function of time. So it looks like they did 30 pies in 2 hours, 40 pies, or 60 pies in 4 hours, and in 6 hours they made 90 pies. What is the rate of pie production? Well, okay, this is a constant rate because it's a straight line. So all I got to do is just take any 2 of them. I'll take these 2 and subtract the y's and subtract the x's. So xy again. So in this case, I'm going to do 50 minus 30 over, or 6, I'm sorry, that's a 6. 60 minus 30 over 4 minus 2. So in that case, 30 over 2 is 15. And you can kind of see that right here because look, it goes up 15 over 1, up 15, or up 30 over 2 is the same thing. You can do rise over 1 and divide it. So it's 15 pies per hour. There you go. That's the answer. Letter G. And finally, the last page, we made it. It says, shows the speed at different times riding a bicycle, uphill, downhill, and on level pavement. So in this case, how long were you going uphill? Now, here's the tricky part of this one. How long were you going uphill? Well, if you're going uphill, your speed does not mean a person's going up. It means their speed increases. So in this case, when you're going uphill, your speed is probably slower, right? So that's this interval here. Tricky, tricky, tricky. So your speed is decreasing if you're going uphill, right? Because it's harder to pedal. So you are actually, how long were you going uphill? This is going downhill because your speed's increasing. And then you're going uphill because your speed is going back down, right? And then you're probably stopped. So in this case, how long are you going uphill? That would be from 3 minutes to 6 minutes, which is 3 minutes. Don't be perceived by the picture because it would mean your speed's going up. When you're going downhill, you gain speed, right? So you must be going downhill from 0 minutes to 3 minutes. 3 to 6 minutes is 3 minutes. And 0 to 3 is also 3 minutes. And how long were you riding on level pavement? So your speed is consistent when you're doing that. So 7 to 10 is also 3 minutes. So you did 3 minutes of each, basically. 3 minutes to get up the hill, 3 minutes to go down the hill, 3 minutes to go up the hill, and 3 minutes on level ground. Okay. Then the very last question. Given a plot of values, is this linear or non-linear? Okay, linear would mean it looks like a line. Non-linear means it's going to look like a curve. So if you think about it, negative 2, 5 is right here. Negative 1, 2 is right there. 0, 1 is here. And then it starts to go 1, 2, and 2, 5. So basically, this is not going in a straight line the whole entire time. This is actually, and we would get to this pretty much at the end of the next couple of units. This is what we call a parabola because it goes around like that. It's also known as a quadratic. But basically, you can tell it's definitely not a line, right? It's a curve. So in this case, our answer would be non-linear. And you'd also know by looking at your table, because the table doesn't go up and down at a constant rate. It goes down 3, down, up 1. It goes down 1, up 1. That's not a constant rate, right? And it goes up 1 and then up 1. So it's like kind of confusing. Not working. And then up 3, up 1. So it's not a constant rate. Okay, that's it for this packet. You have done everything there is to do from what we sent home in the first round. And again, I'll be sending more through electronically this time. There's not a packet pickup as far as I know right now. So I'll be sending you things shortly. All right, take care.